I would like to go through everything that we have so far for the people in my uh, Discord group. So this is basically a remake of Pac Man, and I'll try to explain everything in detail. So at the moment, we just have simple controls and simple win condition. Not win condition, but when you collect the stuff, you reset the time. Uh, you can just move. Those enemies are not do not have a script yet, do not have controls. And you have these areas here on in the corners where you can teleport to the other side, you see. Uh, the same goes for this one here. So you can teleport like in the original game. Okay. How did I draw this with the tile maps? So I have a tile map for the ground and a tile map for the walls, and I use the collider to give physics to each tile that is a wall. Let's go through the player script and the game manager script, and I should comment every line and explain everything. So for the player, we need a couple of things. We need a sprite renderer because we're displaying an image, the animator to manage animations, rigid body for physics, and then we have a reference to the game manager. Um, this is the visual effect when you interact with the collectible. And then we have a move speed and a bull for running, so we know if you're running or not. So the start function, this whatever you put in here happens when at the beginning of the existence of the object. It happens once and in one frame. So here we get the components and place them in the variables. And by default, we say is running is false. And then in the update here, whatever we put in here happens every frame. So for each direction, if we are moving in any direction, we say is running is true. Enable the animation by modifying the parameter, the animator. And then we give a velocity. So that means a speed and direction in the rigid body. So for each direction, each key we have a different direction. But for left and right, we also want to flip the sprite so that the player looks in the direction in which it's moving. So here we flip the sprite for the left and right direction. And then if you're not pressing anything, we check if we're moving. And if we are moving, then we stop moving with this. So we set the speed and direction to 0. That's what this means here. And we disable the animation in that case. Excuse me. Uh, so here, this is the on trigger enter 2D function. So whatever you put in here happens when you collide with the trigger. So that means a collider without physics. So if you collide with that, we check if it is a collectible. If it is, then we decrease the number of collectibles in the game manager. We spawn the visual effect, and then we destroy that collectible object. And then we check if there are no more collectible objects. Then we use the onCollect function from the game manager. So we respawn those collectibles, and also we reset the timer back to the maximum value. And then here, this is for teleporting. So when we collide in the not corners, but when you teleport, let me show you one thing. So for these areas here where you collide with an invisible collider, here you teleport to the other side. So that's why we check here for teleport collider. So those are just empty objects with the collider. Let me show you. So it's just a collider here with the teleport collider. and it has a script here where we just need to know where to teleport. So we have a vector tree here, so we know where to teleport. And here, when we collide with that, we say that the position of the player becomes the teleport position from the script from that collider. So here, the collision, this represents the object, then we get the script, and then we get the vector tree. That's the position where to teleport. So that's the pair, the game manager here, not that complicated. Uh, those collectibles, because we want to respawn them, in here we spawn them at the start of the game. And then we save those in a variable because we save those in a variable because we then want to count and see how many collectibles there are. So here, let me comment this line here. This means find how many collectibles are, and you place them in this variable. We have a timer, so when the timer finishes, the game is over. And also we have a bool here for controlling the game, so we know if the game is over or not. By default, it's false, so it's not over. And if the game is not over, here in the update we decrease time from the counter. So this means this is a float variable with the time set with 60 seconds, with 60. And then this means we subtract the time difference between frames. So in other words, we subtract the time every frame, and then if we reach 0, then it's game over, and we update the text to 0. Because this is important, because we cannot just say this is equal to that timer, because that now is below 0. So we set it to 0, not the timer counter. Okay, and then if the game is not if it's not over, so if there is still time, we update the UI to the timer. But you see, we have to convert it first because it's a float. We convert it to an int, so the closest int, and then we have, because this is text, we convert them to string here. And then we have this function here. When we collected every collectible, we destroy the holder of the collectibles, reset the time. Let me actually comment this. So this destroy a holder of collectibles, and then here reset time back to maximum. Okay, so let's see, and then we spawn the collectibles again, which if you those collectibles are child of an object. I call it a collectible holder. So we spawn it and save it in this variable at the same time. So you can actually spawn something and place it in a variable at the same time. So we place it here, so we get that variable is equal, and then we spawn it. The first variable here is what we spawn. This is the position, and then this means no rotation, but you can actually put any rotation here at the end that represents the rotation. And then this is just a transform, so we say dot transform. So we don't want the whole object, just a transform component. And then we set the number of collectibles back to the maximum. So the child, how many children this holder has. That's everything. So now we can continue. I made a couple of enemies here. Now I need to know these these have the same behavior, like all of them behave the same.
Technically they're different in the game, but it will be perfectly fine if they all act the exact same.
Okay, so I was thinking maybe we put this here. Like, let me show. Actually, it's easier to show than to talk. So, what if I put this in the beginning inside these areas like this? You see? And oh, wait, that's what is that? That's the camera. One second, let me. I don't want to see the camera. How do I disable it? I don't know actually. Yeah, I see. This is the camera. I don't want to see that, but don't know how to fix that. Let's see. Mushroom. Big trunk. Oh, this one is incorrect. One second, I made a mistake with this one. It does not have the correct sprite. Uh, needs to be this one here. Okay, and then this guy. So I was thinking in the beginning, these guys sit here, and then some parts of this wall, these walls disappear. What do you think about that?
That that's fine, but would it not be easier to just have one of the wall sprites just be like a door that they can exit, but the player can't, and have it be like a one-way door so they can't go back into it?
Yes, that is possible, but
Because wouldn't the player be able to, if the wall disappears, would the player not technically be able to like trap themselves in the box if they accidentally went into it?
um, no, actually no, and I'll explain why. The reason is very simple. Those collectibles are not in the boxes. So when you reset uh, the so when you collect everything, these guys will respawn in the boxes, right? With
Okay,
the holes closed. But since the player never since the collectibles are not in the box, when you reset this, the player will not be in the box, right? So we don't have that problem.
okay.
Um, Now, question is, yes, we need to do a couple of things if you want to do it like this. We need first of all to delete some of these walls from the tile with the tile palette, so that we can add some sprites instead, with colliders, and we take those and then use those, because we I'd like to add a visual effect to that as well, so that the transparency of the wall fades and then it disappears physically. So that's the idea. Uh, so let's do that right now. Tile palette. And when do you need the game?
Pardon?
When do you need the game?
Finished?
Yeah. Yes.
Preferably before Wednesday, I think.
Wednesday. Okay.
I, I don't know if that's too soon or anything. Like, I don't want to put pressure.
No, it's okay. I guess. Uh, let's do it like this. Okay. And then we add some. Oh, my bad. Okay. So let's see. Each one would be. So that would be the default position for this, for the enemies. But I don't have a script for the. That will be the tricky part to make the AI for the enemies. So now let's go to. Actually, why don't I just. Ah, wait, I moved this around and now I cannot place it back. Sorry. Okay. Yeah, so we need a holder for these walls. So let's call this um, enemy spawn walls. Call it that. So we need a 2D sprite square this needs to be the same layer as the walls, which are in layer 1. Okay, and now this needs to be tiled. So here in drum mode we say tile, and now we have to find that exact tile from Pixel Adventure steering. Okay, now I have to resize it to be the exact size of that, which is I think 0.25. Okay, so that is one tile, but we need 1 by 3, so 3 like that. Okay, now this needs to have a collider, so box collider 2D. We resize it so it's 3 on the Y cover, so it covers the whole sprite. Okay. Um, now we just have to position this, which is hard to be perfect, but I don't know if it's perfect. No, it's not. Okay. Now the good thing about this is that now we can just I can wait one second. Now I can just duplicate it, and then on the X I just remove the minus, and now it should be on the other side, you see. So that's the good part about this. Now I can just move it on the Y-axis, so I duplicate it again, and move it just on the Y because the X is already in the correct position. And now I can duplicate it and put minus here for the X goes to the other side. Okay. Zoom in. Okay. Now let's copy this to the other side. Oh, not like this. First duplicate and then that. Duplicate. Okay. Now duplicate this and put the other side. Now we have these walls that we can delete. Okay. I guess we need a script so that we can fake the transparency before disabling this. So let's say spawn wall like that. Make an empty script, and I'll show you something that you don't know about. It's called a coroutine. I'm not sure if I explained that to you. So basically, a coroutine is like a function that you use when a process takes time. So you have to wait some time in the coroutine. And
Okay.
I'll show you in a second. We'll use this to fade the transparency and then delete those walls. Let me copy this from here. So for this, let's delete everything and create a coroutine so that if you say I numerator, give it a name. So let's call fade transparent, fade alpha, the transparency. So this is a bit so this line here, yield return means 1 frame. So in a coroutine you wait some time, you have to wait, and you can wait a frame like this, or you can wait in seconds. So if you say return yield return new wait for seconds, then that means wait and then you specify how many seconds. That means wait 2 seconds. So this is used for processes that take time, and this is a for here that counts time basically. So I know you're familiar with fors with integers. So you create an integer, and you know
Yeah.
basically that represents how many steps you do in this for. But this is a special for. In this one we count time, so we start from 0 to 1, so that means 1 second. We add the time difference between frames every frame, so we wait a frame, we add the time, we wait a frame, we add the time. But we want this to last not 1 second, but how many seconds we want, so then we divide by time, so that represents how long this for will last. So here let's make a public float fade time, call it fade time, and replace it here in the code. Uh, okay, and in here we want to modify the color of this wall, and for that we need to have the sprite renderer component. So let's create a variable for that, and then in the start function we get that, because right now we just have a variable in the memory but with nothing inside it. So say it's equal get component sprite renderer, like that. And now here we don't want this stuff. Let's delete that. We want the alpha of this sprite renderer, but you cannot modify the alpha directly. You have to modify the whole color. So we will say sprite renderer color. Wait, not that. So color becomes a new color. Create a color every time, and now we maintain the colors. So in Unity, colors are made with red, green, and blue. So we say we maintain those red, green. I think yes, red, green, and then blue, like that. And for the transparency here at the end, we'll use something called matef lerp. Uh, but yes, so from 1 to 0, and then here the t. So I'll explain this. It looks complicated, but it's not that complicated. uh, and also let's say public void start wait alpha. Okay. So we say start. Uh, okay, so we made a function so we keep the coroutine private, but this is a public function that will start it. So to start a coroutine, you can't just say the name fade alpha. You have to say start coroutine and then name it inside. So every frame we change the transparency by changing the whole color. So you see we maintain the colors, but the transparency is changed, and this here means matflurps means we select a value between a starting value and the ending value. Okay, so the starting is obviously fully visible, so alpha 1, um, and then to 0, we want to go to 0, so completely transparent. And this t here means it's from the 4 here, so it goes from 0 to 1, and that will represent where exactly between those values. So from the starting value to the ending value, we select a value with this t. So if this t is 0, that means the starting value, and if it is 1, then that's the end value, and if it's between, then it is between these values somewhere. Okay, but the issue is since this t here goes uh, is not it's not exactly 1, we have to say here at the end that the color is um, equal to new color. And now we actually let's copy this. But this but here at the end we just say transparency of 0, because it's not perfectly 0. It is 4. So that will fade the transparency, but then we want to disable these walls. Um, so let's just say let's get the collider here. The private box collider 2D. Box collider. So create a variable. We get it with the get component. Box collider 2D. And here in the coroutine, after we fade the dance, so let's say here fade transparency. Uh, Now we disable the collider. So box collider enabled. It's false. And that's it. Now we just need a function to revert it to normal. So let's say public void reset reset wall reset wall. So for this we want two things: to color the color to go back to uh, yes, the color white, color white. So reset the color and then enable the collider. So box collider enabled is true. So we want this when the enemies respawn. Okay. Okay. Now here in the game manager, um, we want to create this to do this at here on collected, but I'd like to have it here in on all collected, but let me think 1 second because we want to destroy this only if there is one. So let's say if or actually never mind, just keep it separated. Uh, let's say public void spawn respawn enemies. Okay, so the first thing is now I'm not very that familiar with the Pac Man. What happens if you eat the enemies?
They basically turn invisible. Like you can't interact with them
And then
when you eat them, and they retreat back to where they spawned
oh,
and
I
then
see, I see. Okay,
respawn.
okay. So in that case, we need here actually let's have a public um yes public yes public game object. Uh, do we need a game object? I don't know. Let's actually say enemies here. Do I have an enemy script? No. Uh, yes. So we need to save those enemies in an array so that when we collect everything and they respawn, we can move them to the starting position. Uh, but first, oh, we have an enemy script. Okay, that's good. Then we can just say public enemy array and then uh, enemies enemy scripts enemy scripts. We'll do it manually because uh, they're just for enemies. Um, so let's use the respawn enemies function. So when we do that, we want to put it each one at its original position. Okay, but we do not know that position. So first of all, let's add the enemies here to the array like that. So now we have each one. Um, in the enemy script, we want to save that position, that initial position. But I do not have that script open. Let's see. Select that enemy, open it from the interface. So before we start the AI, let's just say public uh, public vector3 starting position, vector3 starting position, and in start we just say starting position is equal to transform position. So now we know the starting position. And then here in the where is it, game manager, so first step, we place enemies at their original position. So for integer from 0 to well, let me show you something else. You can also do this. You can say for each and then say um, enemy in enemy scripts. So that will go to each element of the array. And then we say enemy transform position becomes enemy starting position. Replace each one at the starting position. Yes, and then for the walls here, we need to reset all of the walls. But for that, we need the holder of these walls. So let's say here, public game object enemy walls holder. Not what? No, let's just make an array. So spawn wall array. Just call it enemy walls wall scripts. And then here, each wall, we reset each wall. So let's do that again for each, but this time wall. How is it called? Spawn wall. Okay. Enemies. Let's call it spawn wall scripts. So for each spawn wall in spawn walls scripts. So like that. And then we say reset reset wall. So that should put the enemies inside the walls. Okay, now we have to go to the game manager and here add all of those walls. So how many there are? 1, 2, 3, 4, 8, I think. We have to put them individually here, but they do not have the wall script from what I see. So let's add that spawn wall. Wait time 2 seconds, and now we can drag them because the issue was we did not have the script on the walls. Okay, now we have those. And I guess it's time to do the complicated stuff, which is the enemy AI. And I have to think 1 second about this because for AI there are many ways to do this. Uh, yes, I have an idea, but it's not super easy to do. So my idea is we have some checkpoints here on the level in positions only in the positions where you can change moving direction. So for example, let me use a square to demonstrate this. So for example, let me access that one. So for example, here it's a point where you have to decide if you change direction, you can go in that direction, or for example, this corner here. So that's a point where you have to decide if you want to change direction. Um, so that's what I'm thinking. Place some colliders in places where you have to change direction, and then when the enemy collides with that, we have an array with the possible directions, and then they select a random one, so they move randomly. Is that good for you? Sorry, I cannot hear you. I cannot hear you. Hello. Okay.
Yeah, what?
Did you hear what I said?
I was literally just running to the bathroom there.
Oh, sorry, sorry. So I was explaining the AI of the enemies. So I was thinking maybe we should have checkpoints in places where you have to decide if you move in a direction. So you see, I demonstrated with these squares here. So this is a place when you where you have to decide in which direction to go. So the idea is we have these checkpoints, and when an enemy interacts with it, it has to go to a random direction. That is possible. So these results, these checkpoints also will have a script with a list of possible directions. So is that good for you? This random movement?
Yeah, that's grand.
Okay, that's good. Then we can start coding. But first, we have to create the checkpoints. So let's make a empty object that will hold all of this. Call it enemy checkpoint points. And now we have to create one, and we have to decide how big, how large the collider should be. I think it should be very, very small, like that. Um, yes, something like that.
I, I think in the game they move randomly, so
Oh, that's good. Let's call it check enemy checkpoint. And we'll use a strategy to make this. We'll draw one side of the map and then copy everything on the other. Oh, actually, never mind. That's not that simple. Okay, it's not that simple, but this will take a while to do. But okay. Uh, Now the issue is, uh, I'm afraid that some of these enemies might not collide with these. So I think this has to be very, very small. Actually, not even that. Even smaller. Uh, Let me see. What possibilities do we have for colliders? Colliders. Edge collider. I don't know. Maybe even smaller. We'll have to test this. That's super small. I don't know. Sorry, I have to think about this. It's not that simple. Okay. Let's do it, try like this, and if it doesn't work, we'll have to think of something else. So this square must also have a box collider that is trigger, so we can detect. And let's call it here in the target. We'll call it enemy checkpoint. Okay, let's call that that. Call it that. Uh, and let's give it green. Green is not red. Oh, it's white better. It's white better. Okay. Now we have to. Okay. So place we have to think of every place where you can change direction as an enemy. Okay.
Okay.
This is a one of them. Also here. Here. Here is a point. Here is another one. Take a while, unfortunately. And you let me know if I miss spots here. Oh, here it is, another one. Okay. Uh, yeah, this will take a while, but it's necessary. Uh, yeah, here is also a point. Okay. 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 Oh, that's also a point here. I guess we'll find if we miss something while testing. It will not be easy, man. We have to go through each of these and give them the possible directions. This will take a while. Lot of work. Okay, I think we might want to take a break and like stop the recording. Okay.